everyone. I want to go over the problems for your test on Thursday. A few struggles simply because I think it was manipulating the formulas. So a couple of things that I noticed. One being, some of you did not fill in this section here. So I'll go over that real fast. When we're talking about potential energy is always measured in joules. M is referring to the subject, and mass is always in kilograms. Little g here is gravity, and that is always 9.8 meters per second squared. We're talking about height. Height is also, it's just a distance, so it's measured in meters. All right, so this one here kind of set it up for you. The question is, the world record for pole vaulting is 6.15 meters. If the pole vaulter's gravitational potential energy is 4,942 joules, what is its mass? Okay, so we're for mass here. So cover up the M on my formula triangle. My formula is going to be potential energy divided by gravity times height. Now, many of you set this up correctly, but a few of you forgot about gravity. It was not named in the problem, but if we're talking about gravitational potential energy, we are always going to be making sure we include little g here. So my energy was 4,942 joules. And then I need to make sure I multiply gravity, 9.8, times its mass. And its mass was, I'm sorry, so height. We're going to multiply its height, which is 6.15 meters. So the first thing I'm going to do is multiply 9.8 by 6.15, and that is 60.27. So then I can just go ahead and divide now. So 4,942 divided by 60.27. And what I got was about 82 kilograms. Another thing is, some of you left off units for your answer. Please make sure you include units the thing to have on your answers. Otherwise, I won't know if you're talking about 82 meters, 82 joules. Of course, solving for mass, so it has to be in kilograms. I'm going to go down to the next part of the worksheet that was talking about kinetic energy. So again, kinetic energy is always measured in joules. You'll notice they do the units here. M is mass, so again, kilograms, and velocity is again meters per second squared. So we look at our first problem here. A cheetah can briefly run with a speed of 31 meters per second. Suppose a cheetah with a mass of 47 kilograms runs at speed. What is the cheetah's energy? Okay, so kinetic energy in the problem, I don't know what it is. Solving that, they said the mass is 47 kilograms and the velocity is 31 meters per second. So for kinetic energy, that's a nice plug and chug problem. So kinetic energy is equal to 1/2 my mass times my velocity squared. This is where a few people had a mistake. Some of you put in the equation correctly and you put in the correct variables. However, you forgot to square your velocity. So when I'm solving for this, I'm going to 1/2 my mass, which was 7 kilograms, times my velocity, which was 31 meters per second, and I have to square that. Again, as I mentioned in the video, for your lecture notes, it is, of course, I need to square my velocity first. So 31 squared is 961 meters per second. So 961 meters per second. Now I can go back and multiply. 961, or actually we can do, yeah, so 1/2, 37 times 961. I got 22,580. And I'm going to put joules. You could have rounded, there's a decimal 0.5 right here. So 22,584 joules. That would be the correct answer for this. So when you're completing your study guide, come back to this worksheet, reference it, go to your kinetic and potential energy worksheet. For the most part, I've graded everyone so you can see where you've made your mistakes. Keep in mind to square your velocity when you're doing kinetic problems, and when you're doing potential energy, do not forget about gravity.